Welcome back to the channel, people of the Commonwealth. So today I'm going to continue on the previous videos. I'm going to explain what are vector databases and how to use the vector database instead of a cosine similarity function that we used earlier. Right, so we need to replace it with a real, actual, usable and scalable vector database. So vector databases are nothing just specialized databases designed to store, index, and for searching purposes. Right, they can store the vectors, embeddings, and we can retrieve those back very quickly, and it can scale up to billions of vectors very fast. So they are especially useful in AI and machine learning applications where the similarity functionality is more important than exact matches, right? So traditional databases are exact matches, and these vector databases are like similar matches, right? So this is one of the images that clearly explains how these databases work. So key value pairs are basically like MongoDB, etc. We have key and value. You can store accordingly, or the traditional databases with IDs, right? Documents, databases based on documents, like they are related. Similarly, like graph databases, they have relationships on to different objects, and those objects have relationships to other objects, and this goes like a graph. Meanwhile, vector databases can be visualized like this, and they have similar functionalities, and we can search any point in this xy axis, and we can get multiple results based on which has higher probability. So you can get multiple results in vector databases, but not in the traditional sense, right? So what are popular vector databases these days? So there are several from Google, Microsoft, and Facebook. One of these which we are going to use is FAISS, Facebook AI Similarity Search. It's an in-memory, fast, and scalable vector database. There are several others: Pinecone, Qdrant, and others. All are scalable. You can use any of these, right? So I'm going to use this Facebook one, FAISS, and change the previous code that we ran with cosine similarities. So this can be done directly by the database itself, and they also provide like advanced indexing techniques, quantization, and other techniques. You can go into more complex stuff later on, but for now we just need to see how the real database works and how we can use it to store vectors and retrieve those vectors, right? So I'm gonna run this code just like before. We need NumPy, FAISS. This is the vector database library from Facebook, right? And then we load our API key into OS, same code as before. You can watch the previous videos to set up these again, right? We are on the third step of vectors. So now we need the function to get the embedding from OpenAI using the API key, and it will create the vector using the cheapest model available. So we can get our query vectors or document vectors, right? So we are using these dummy documents, tips to improve a tech resume, how to write a better LinkedIn summary. So these will be our documents that will be stored in the vector database, right? And for each of these, I'm just running a simple query that will fetch their vectors from OpenAI and store those into doc vectors variable, right? After this, I'm gonna run this. After this, what we are gonna do is this is the FAISS code, right? So what we have to do is to use our vector database. Instead of computing cosine similarity manually, we'll need to build an index from our documents embedding and then query it using our query vector. So this is how it works actually. So this is the dimension. We get the shape of the doc vectors, which is 1536 in our case, using that model. Okay, t time, guys, just a second, let me get back. And I'm back. So now we have index, and we just give it the dimension, and it will create an index for us. Actually, ignore this for now. Inner product equals to cosine. If vectors are normalized, we'll get to it later on. After this, we have to just normalize the document vectors. Normalize L2 will do that for us. After this, we just add all the normalized vectors to our FAISS index, right? And now our vector database has those given vectors stored. After this, now we have our query, how can I improve my resume for tech jobs. We simply get the embedding for the query from OpenAI GPT, and then we reshape it for the proper structure, and then feed it, normalize it using FAISS, right? So normalizing is done for cosine similarity, and this reshapes the vector into the input that FAISS requires, right? So after this, we have this. We are going to fetch the top 3 similar documents to our query, and we are going to get the indices and the distances, the scores, and we are just going to print those for result. So the most similar document to our query, how can I improve my resume for tech jobs, is this with a score of 0.8663, tips to improve a tech resume, and 0.4 score with this, how to write a better LinkedIn summary, and guide to cracking software engineering interviews with 0.4 score, right? So the distance is the distance, or the score you can say, is the similarity score dot product of normalized vectors, or you can say cosine similarity, right? Simply we get back, we have gone a whole circle back to cosine similarity, but this time we are using FAISS, and this will be used for further more complex projects instead of directly using those functions. Okay guys, I think that's it for this video. See you next time. Thank you.